Hello class, today what we are talking about is properties of similar right triangles, okay? And yes, these triangles are similar, but that's not what we're talking about. What we're talking about are these right triangles, all right? So if you have an altitude drawn from the right angle to the hypotenuse of a right triangle, this creates two new triangles, and all three of these triangles are going to be similar to each other, all right? And so what we're going to do here is identify which these similar triangles, okay? And it's not saying, hey, this one's similar to that one. We need to specify which angles correspond to which angles, right? We're going to write a similarity statement. And one thing that can help with that is to draw each of the triangles out, all right? So here we have all three triangles. You've got the little one, triangle TSU, and we've got triangle RTU, and we've got triangle RST, the original. All right. And when you have them out like this, it's a little easier to see which angles correspond to which angles. All right. And so we have triangle TSU is similar to triangle RTU is similar to triangle RST. Notice, just because an angle has the same letter does not mean it corresponds to each other. All right. Here, angle S corresponds to angle T. All right. Here, angle T corresponds to angle R. Angle T, in fact, in none of these three triangles does angle T correspond with angle T. All right. Some of them angle R corresponds together, some of them angle U corresponds together, but sometimes the angles don't go together at all. All right. So you've got to be careful with that. So what I want you to do here is write out the similarity statements for these three triangles. All right. Pause the video, write those out. All right, let's see how you did. For triangle 1, should be triangle QST is similar to triangle SRT, similar to triangle QRS. You might have these in slightly different order, but Q in the small triangle corresponds to S in the middle triangle, which corresponds to Q in the large triangle. All right. S, this is the easy one. This is all the right angles. S corresponds, S is not the right angle, not this one. Angle S is in the little triangle, corresponds with angle R in the middle triangle, which corresponds to angle R in the large triangle. And then we have angle T, which is the right angle. So we have angle T to angle T over here to angle S in the large triangle. All right. And here it is for triangle 2. Let's take a look at this. What we can use with this? Well, since they're similar figures, we can do stuff with them. So here we have the cross section of a roof. We need to know how high is the roof. It tells us this roof is at a right angle, so it's a little odd looking, but that's okay. So we know the length of this side of the roof. We know the length of this side of the roof. We know how far it is across the house. All right, so we know how high it is. Well, since this is an altitude that we're looking for, and this is the right angle, we can use those similar triangles. All right. So, write out the similar triangles. And here we have them all written out, drawn out, so we can see which sides correspond with which sides, right? And which sides we know the lengths of and which sides we're looking for. All right? So here we're looking for side H, here we're looking for H. It's the same length, but it's in different places, right? Here it's the short leg of the triangle, here it's the long leg of the triangle. All right. So we can use either of those. All right. Any two of these, it really doesn't matter. Well, it does a little bit, because we can't put these two together, not if we're looking for H. Because H doesn't correspond with H, right? And so that's a problem. But we can use this over here. All right. So here we could use YW, which is right here, or maybe right here, and YZ. Okay, so we're using this one. So we're going to use the hypotenuse and the short leg. That's what we're using. So that's going to correspond to the hypotenuse and the short leg of the original triangle, the whole thing. Plug in our numbers, cross multiply and divide, solve our proportion there, and we see that the height of this triangle is 2.7 meters. That's how tall this roof is. All right. So that's not too bad. Alright, so what I want you to do is pause the video and find the value of x. Alright, might help to draw out your triangles and then set up your proportions. Okay, so pause the video, work out the value of x, and then come back. Let's see how you did. There's for number 3. There's for number 4. Alright, so if you got those right, great. You can fast forward the video a little bit. If you didn't, let's see why not. Alright, so here on number 3, I've drawn out the triangles. I'm looking for x, so I can either use hypotenuse and short leg here, or hypotenuse and long leg over here. And I'm definitely going to want to use this triangle because it has both of those no matter which way I go. Alright, so just so you can see that, here is using EF and FG, so hypotenuse and short leg, which set up a proportion that gives me 5 times x and then 3 times 4. Right? And here I've done it using hypotenuse and long leg to hypotenuse and long leg over there, which again gives me 5 times x and 3 times 4. Right? So either way, you end up with 5x equals 12. So x equals 12/5 or 2.4. Right? And here it is on triangle JKL or JLM. Either way, and it works the same way. So you can either do hypotenuse and long leg or hypotenuse and short leg. Definitely want to use the original triangle because it's got both of those values already in it. Alright, so let's take a look at what we have next, and that is the geometric mean. Alright, the geometric mean is not the same as the arithmetic mean, which is what you've used all the rest of your life up until this point. Alright, this has nothing to do with adding things up and then dividing by how many there are. What this is if you have two numbers, x is the positive number such that a over x equals x over b. It sets up as a proportion. Well, you can cross multiply and divide that, and you end up with x squared equals ab. So x equals the square root of ab. And we definitely do want the positive x value. All right. And so real quickly, we're going to work a couple of these out. Well, we're going to work one of these out. Geometric mean of 24 and 48. All right. So the geometric mean is this x squared equals a times b, right? So here's a, here's b, or vice versa. It doesn't matter. And so x squared equals 24 times 48. So x is the square root of 24 times 48. And we're going to go ahead and simplify this. 48 is 24 times 2. So here I have 24 times 24. So this is 24 squared. So the square root of 24 squared is 24. And I've just got the 2 left over. So square root there. So x equals 24 square roots of 2. Right? Or approximately 33.9. And they just simplified that. And so that is geometric mean. X squared equals AB. And I know you're saying, what does that have to do with right triangles? Well, here's what this has to do with right triangles. When we have that altitude drawn from the right angle to the hypotenuse, what happens is the altitude is the geometric mean of these two segments that it forms on the hypotenuse. All right. What also happens, and is also kind of cool, is that each leg of the original right triangle is the geometric mean of the segment that is adjacent to that leg and the entire length of the hypotenuse. Right? So here, this leg is the geometric mean of this little piece and the entire hypotenuse. And over here, this leg, AC, is the geometric mean of this longer segment and the entire hypotenuse. All right? And so that's useful, and that way we can use this to find things out. So we're going to have geometric mean with the altitude or geometric mean with the legs. Either one is good. All right? So here we need to find the value of each variable. Okay, so on A, we're looking for the altitude. So we're going to use that altitude one. So the altitude is the geometric mean of these two segments that we form. Right? So that means x squared equals 6 times 3. Well, 6 times 3 is 18. Square root of 18 is the square root of 9 times square root of 2. So 3 square roots of 2. Right? Over here, though, we don't care about the altitude. We don't know what it is. We don't care what it is. We do care about the leg of this original right triangle. But the leg of the original right triangle, remember, is the geometric mean of the segment on that end of the hypotenuse and the entire hypotenuse. All right? And that's what people forget. It's to the entire hypotenuse. So we have y squared equals 2 times 5 plus 2, or 2 times 7, right? So 2 times 7 is 14. Square root of 14 is, yep, that doesn't simplify, so that's just the square root of 14. All right? Now, another cool thing you can do with this is you can use this to measure things that you can't actually measure because they're too big or they're too far away and you don't have a tape measure that big. All right? And so what they're doing here, they're going to install a rock wall, climbing wall for their school gymnasium, and they need to know how tall that wall is. But they don't have the blueprints and they can't measure it with a tape measure. So you use this right angle here. So you get a piece of square cardboard or whatever, and you line it up so you can just see the top of the wall at the top of the square, and you can just see the bottom of the wall on that bottom corner. And that sets up a right triangle for you. And then you measure from the corner of the right triangle, or the square, to the wall, and that creates an altitude. And then you need to measure how high your eye is, right? How high you're holding this. All right. And so you have one leg of the little triangle, you have the altitude, and you're looking for this other leg of the other triangle. And so that's geometric mean. All right, so we've got the geometric mean as our altitude, 8.5 squared equals W times 5. Multiply that out, divide by 5. Now remember, this is just W. This is just the part above your eye level. All right, so you've got to add that 5 back in. And so that gives us 19.45 feet. All right. So that's kind of cool. It's a way to measure things that you can't actually go out and measure because you can't get to the top of it or whatever. All right. So what I want y'all to do is these 5 problems here. On number 9, you might want to back up, look at this, draw that out so you can see where this goes. And pause the video, come back, let's see how you did. Here we go. Alright, so hopefully you got those all right. If not, if you did, great, you're done. If not, let's see what you messed up. So these first 3, this is just geometric means. So x squared equals 12 times 27. Take the square root of that, and square root is 18. So not too bad. Number 6, same thing. 18 times 54, square root of that. We want to simplify that, and we end up with 18 square roots of 30. Same thing on number 7. Simplifies square root of 288, and we end up with 12 square roots of 2. Alright, so number 8, though, we need to find the length of x. And so we look at this and we say, okay, this is the altitude, so that means this is my geometric mean. So x squared equals 4 times 9, which is 36. Square root of 36 is 6. Okay, so now let's take a look at 9. Same thing when we want to measure the height of that wall, only for this person, the eye level is 5.5 feet, and they're standing 9 feet from the wall. So here's a picture. We look at 9 feet from the wall, 5.5 feet. So this is my altitude. So this is my geometric mean. So we'd have 9 squared equals this little piece times x that I'm looking for here. So 5.5x. So 81 equals 5.5x. We take the square, we divide both sides by 5.5, and we end up with x equals 14.7. Now remember, that's just this top part. We want the entire wall, so we've got to add that 5.5 back into it. And so there's that 20.2. All right, and so there it is. That is similar right triangles created by the altitude there and the geometric mean. And so that's kind of useful. You can use it for indirect measurement and things like that. I hope this helped, and I will see you next time.